I'd like to show you some more of the capabilities of my graphics card. First, I shall send a picture to it straight into the video memory. Here we have the obligatory Gordian Finch. I also have another one, which is the one I've been using quite a lot in my tests for my first ROM only graphics card. This is fairly simple demonstration. One thing I like to show you is the Gigatron picture. Because I'm using exactly the same resolution and colors as the Gigatron, I downloaded the Gigatron picture from their website and converted it over to my picture format. So it's exactly the same. Should be. Except I'm generating it on my video card on my Crazy Small Computer VGA 8. Not a Gigatron, but it looks exactly the same. Another thing I can do is I can show you how to scroll it. So instead of sending a picture straight into the video memory, I'll load up an application, and I'll pick my scroll up. So this will scroll up the screen by 1 pixel each time. So you can see that it's scrolling up by 1 pixel. It looks very wobbly because the amount of time it takes for the memory to be read and then rewritten 1 pixel up is quite a lot. There's over 19,000 bytes, and as it's only a just over 3 megahertz processor, 8-bit processor, that's going to take quite a while, so you can see it. But it works. It reads the video RAM and it writes it back. So that's one scrolling. I can scroll it the other way as well if I just load up the scroll the other way. So now I can scroll it to the left. So you can see just reads the memory, writes it back 1 pixel to the left. Not too difficult at all. What makes my graphics card different from many other ones I've seen, especially the Gigatron, is the fact that I can use what I call a subpixel mode or a text mode, where I can break 1 single pixel down into 4 separate pixels, and that will give me like a higher resolution for text. And I'll just show you what the text looks like if I can find it. Let's clear the screen first, and then hopefully this is the right thing. There you go. That's how big the text would be if I just used normal size pixels. So that's basically the smallest you can get it. That will give you 26 characters by 15, and that's 26 across, 15 down. I got 64 different colors for that, but I can show you my subpixel. Let's just clear the screen first, and the subpixel, let's do some nice colorful text. Here we go. Oh, 8,000. As you can see, you can get an awful lot more characters on the screen there. So you're getting 53 by 30 characters. But the thing is, you can only have 7 colors, or 8 colors, because my color 0, which would normally be black, but because the background's black, we'd have black on black. So I've changed that to orange, because we all know orange is the new black. So that's a little bit of Shakespeare. And another thing I can do is I can change the background color, but I can only change it from a previous pixel. So there's another pixel mode that just changes the background color. So I'll show you another little demonstration. Send file. This is basically the same thing, except it will change the background colors. So it's the same text over by 1 pixel, and then down here, down this column here, I'm changing the background color. But it takes a whole pixel to do that, because the way the card, because it's a very simple way of doing it. So I'm just writing and rewriting the colors one line up, the background pixels. So that looks fairly impressive, maybe. I don't know. So you can have higher text, so high resolution text, but the restriction is the number of colors, and also how you can change the background color. So let's stop that. I have to stop that by resetting the stuff, clear the screen. I can just show you just the same text in one single color. There you go. There you go. We've got it all nice in green. So you have whatever color you like. You don't have to have it multicolored. And you can also scroll that as well. You can scroll, if you scroll up by 4 pixels. Let's do scroll 4. Because in effect, even though it's looks like 8 pixels high, sub-pixels high, it's actually just 4 normal pixels high and 3 wide. So it gives us, I use exactly the same font for sort of when I made it out of normal size pixels. It's just normally it would be 6 pixels wide and 8 pixels deep or high, and this would be 3 by 4 pixels. Normal size pixels, not sub pixels. So it's still 6 by 8 sub pixels. Hope that makes sense. So there we go. We can scroll it up. So I'm scroll out by 4, so it doesn't look quite as wobbly. Of course, it all disappears. And let's put some more things I can show you. Send file 32-bit Fibonacci sequence. So there you go. You got using my text mode. Also using a 32-bit number to store the Fibonacci number, and that's calculating it on the fly. That's not stored anywhere. I haven't stored the data there. That's calculating that and printing it out on the screen in the high resolution. So you can show a lot more things that way. I'll show you with something else with it scrolling. Print. Oops, give me a sec. Can't find the file at the moment. Bear with me. That just scrolls in lots of numbers, normal size pixels. So that's not very useful. Which is the one I wanted to show you. Yeah, that's the one. Found it eventually. Yeah, this is 16-bit numbers, so it just works out 16-bit numbers. Again, it's not. It's getting the 16-bit number and then it's converting it into a string of characters and then printing them out on the screen, different colours. I have to use different colours, of course, because why not? So I'll just show you my new game. Well, not a new game, but a game I've developed for it. Just a simple snake game. Let's clear the screen first. Let's get the game. Games. Snake. And I'm very, very bad at this game, so. Oh, I got one at last. So there's no sound on here, and if you see the actual snakes in different colours depending on its direction it's going, that's on purpose. Woo! Almost hit the side there. That's not aesthetic reasons, there's actually a programming reason for that. It's so that when I erase the tail as it moves forward, I know the next part of the snake is going to be up, down, left or right. So I'm using the actual video memory to store the snake where it is, and I only have to store the head and the tail in the actual RAM, and the rest is in the video memory. So it makes very efficient use of memory. And you can see I've got the word snake at the top, multicoloured, normal size font, and then I've got the score in the smaller font using subpixels. So you can mix and match them. You don't have to change. You don't have to change resolutions to use the text mode. That was really what I was going for. I didn't want to lose the 64 color pixel mode. A lot of graphics cards, they have different modes. So you have a text mode, and it's got built-in font. That would be quicker, you use less memory and so on. But then you can mix that with the graphics. So I wanted to keep both the graphics and better text. So it's still quite chunky compared with normal VGA graphics today, but for an 8-bit computer it's not bad, and it was just a little bit of lateral thinking on my part. I have the advantage of using game over, of modern chips which are faster than say the chips in the 80s, so I'm using very fast SRAM 32K. That would have been exorbitantly expensive back in the 80s. No reason to use dual port RAM for this. I'm not doing too bad. I'm usually pretty awful at this game. And fast HCT chips, so I'm using HCT rather than HC or LS. And it's all on breadboards, the video, and you don't get quite a bad look to it. Quality's very acceptable. I mean, it's better than like a composite video on my Spectrum, color fringing, and the resolution wasn't that great, and I got more colors, but then again I use more memory. Also, the way I produce the signals to give me my subpixels, I use fast erasable EEPROM, which wasn't available back in the day as well. So, don't hit it. I went down on top of myself. So I can just show you. I forget. A little bit of a bug. I can't quit unless I go game over. There you go. I'll just show you my Tetris clone, which I've shown before, but this one's got the higher resolution text on it. Luckily with Tetris there's not really a lot happening on the screen, so you can get quite smooth play even at very low clock rates. So yeah, it's nice and smooth. And there you go, got a line. So I've got next piece, I've got the instructions on the left there. Well, I'm going to put that there. I've got the score. I mean, there's plenty of room on the screen, but it's just an example how to use this if I wanted to use more text. And I've got the ability to use that. Might have hugely chunky text. I haven't really used the background, changing the background colour for the text yet, but maybe I should do that. Let's quit out of that, and I can show you life. I've done a full screen life, and again it stores all the cells in the video RAM, so hardly uses any of the main RAM in the computer to store it, because that would be 19,200 bytes, but I'll just use the video RAM. So the video RAM stores both the current pixel or cells and also the next generation cells, and you can't see it how it stores it because I'm storing it as background colors, so a background color pixels, so it changes it to a white background color if it's going to die next generation, and a foreground white pixel if it's going to be alive next. Anyway, yeah, it runs quite slowly. I can just quickly, if I can do it, I can speed it up by just putting my clock rate up, doubling my clock rate. Sometimes it crashes like that. So I've messed something up there. I've got it running twice as fast, so maybe I should put that back. There you go. That looks a bit better. But it goes slower, obviously. Unfortunately, it's not very stable at the double the clock rate, the actual CPU. So it usually only works if your program's running solely in the RAM, which it is in this case. Okay, well, thanks for watching, and I'll talk to you. I might do a bit more technical video next.